Now we'll look at sum and difference identities for sine. So if you have sine of alpha plus beta, I'm looking right over here, then it's going to be sine of alpha cosine beta plus cosine alpha sine beta. So notice how they switch: sine alpha, then sine beta, cosine alpha, then cosine. So it's sine alpha cosine beta, cosine alpha sine beta. So it goes from sine alpha to sine beta, it goes from cosine beta to cosine alpha. And so really, it kind of switches around. The other key thing is it's plus here, and notice minus here, minus here. So sine alpha minus beta, sine alpha cosine beta minus cosine alpha sine beta. So you use the sum and difference identities to evaluate the difference of the angles. So what do we have here? It's going to be sine of 45 degrees cosine of 30 degrees minus sine of 30 degrees cosine of 45 degrees. And that's going to be square root of 2 over 2 times square root of 3 over 2 minus 1/2 times square root of 2 over 2. So I get square root of 6 over 4 minus square root of 2 over 4. So it's the square root of 6 minus the square root of 2 all over 4. Then sine of 135 minus 120, it's going to be sine of 135 cosine of 120 degrees minus sine of 120 degrees cosine of 135 degrees. So sine of 135 is going to be, that's second quadrant, sine's positive, square root of 2 over 2. Cosine of 120, that's second quadrant, so cosine's negative. So that's going to be negative 1/2. Then minus sine of 120, second quadrant, so sine's going to be positive there. That's square root of 3 over 2. Cosine 135 is second quadrant, so that's going to be negative square root of 2 over 2. And if you weren't sure about those values, just go back up to this chart. So 135 cosine is the x value, sine is the y value, 120 cosine is the x, y is the sine. Okay, where was it back here? So we have negative square root of 2 over 4 minus a negative makes that plus the square root of 6 over 4. And so if I do from the positive square root of 6 minus square root of 2 all over 4. Okay. This next one's kind of fun. Find the exact value of sine of cosine inverse of 1/2 plus sine inverse of 3/5. So just to put it in perspective, we can call this theta. We can call this, why don't we go the other way? Why don't I call this alpha? I'll call this beta. So it's really looking like a sine of alpha plus beta. That's going to be sine of alpha cosine of beta plus sine of beta cosine of alpha. So what we have is sine of cosine inverse of 1/2. And that we can get an angle out of that. Times cosine of sine inverse of 3/5. We don't know the quadrant, so we'll just assume first quadrant. Plus sine of sine inverse of 3/5 times cosine of cosine inverse of 1/2. Now the second part's not so bad because these just cancel. That's 3/5 times, and this cancels 1/2. But over here it's going to be a little different. Now we can go through and we can say, okay, a cosine inverse of 1/2, we can just say that that's going to be, you want degrees or radians. Let's say pi over 3. So sine of pi over 3 is going to be square root of 3 over 2. So that would make this first one square root of 3 over 2. This one's a little bit more work. So given what we have, that's like saying sine of beta equals 3/5. And what we're wanting is cosine of beta. So this cosine of beta is what this is here. So if we drew a triangle, and we call this beta, and then the opposite's 3 and the hypotenuse is 5, call this a. A squared plus 3 squared is 5 squared. A squared plus 9 is 25. So you know where this is going. A squared is 16. And again, we don't have the quadrant here, so I'm just going to say A is 4. So we look at cosine of beta, because that's what it is, cosine of beta, is going to be adjacent over hypotenuse, so it's 4/5. This works out to be 4 root 3 over 10 plus 3 over 10. So it's 4 root 3 plus 3 all over 10.